The distributive property comes out of addition naturally. 2 times 7 means 7 plus 7 equals 14. 2 times the group 3 plus 4 means the group 3 plus 4 plus 3 plus 4. Because there's only addition, the parentheses are not needed. Now, switch around the terms and we get 2 times 3 plus 2 times 4, which equals 6 plus 8 equals 14. So, 2 times the group 3 plus 4 equals 2 times 3 plus 2 times 4, the distributive property. When you add, the distributive property just happens. In the multiplication 2 times 7 equals 14, we call 2 and 7 the factors, and 14 is the product. In the multiplication 2 times the group 3 plus 4 equals 2 times 3 plus 2 times 4, the product is the whole of the right-hand side. The smaller multiplications are part of the product. Let's call them partial products. Let's try this again. 3 times 7 means 7 plus 7 plus 7 equals 21. 3 times the group 3 plus 4 means the group 3 plus 4 plus 3 plus 4 plus 3 plus 4 equals 3 plus 4 plus 3 plus 4 plus 3 plus 4. Switch around the terms and we get 3 times 3 plus 3 times 4. So 3 times the group 3 plus 4 equals 3 times 3 plus 4 times 4. Multiplication distributes over addition. Now let's try this again. 2 times 12 equals 12 plus 12 equals 24. 2 times the group 3 plus 4 plus 5 equals 3 plus 4 plus 5 plus 3 plus 4 plus 5 equals 3 plus 4 plus 5 plus 3 plus 4 plus 5 equals 3 plus 3 plus 4 plus 4 plus 5 plus 5 equals 2 times 3 plus 2 times 4 plus 2 times 5. So 2 times the group 3 plus 4 plus 5 equals 2 times 3 plus 2 times 4 plus 2 times 5. Multiplication distributes over addition. You can see for yourself, it does not matter how many terms in the group. Why bother with the distributive property? Well, you bother with it every time you multiply two numbers. For example, 3 times 123 equals 3 times the group 100 plus 20 plus 3 equals 3 times 100 plus 3 times 20 plus 3 times 3 equals 300 plus 60 plus 9 equals 369. We like to arrange multiplication vertically, but notice the echelon construction and how each digit simply drops into place. This gives us an idea. We do not have to do the multiplication in separate rows. Start with the 3 in the ones position. Each time we multiply the next position to the left, just shift the partial product one position to the left. But what about 3 times 456? Let's try it. 3 times 6 equals 18, 3 times 50 equals 150, and 3 times 400 equals 1200. Add them up to get 1368. Now compare that to the traditional algorithm. When we get a two-digit partial product, the second digit becomes part of the addition in the next column. We have only to carry it over. In other words, the traditional multiplication algorithm is just the distributive property with some shortcuts. Now, let's try something more challenging. What can we do with the group 2 plus 3 times the group 6 plus 7? The trick is to train your eye. When you look at the parenthetic group 2 plus 3, of course you see 2 plus 3. But at the very same time, you must see just the number 5. The parentheses mean the entire group can work like one number. Therefore, the group 2 plus 3 times the group 6 plus 7 equals 5 times 6 plus 7 equals 5 times 6 plus 5 times 7. But 5 comes from the group 2 plus 3, so we have 2 plus 3 times 6 plus 2 plus 3 times 7. Remember that multiplication commutes. Therefore, the multiplication will distribute over addition in exactly the same way, no matter if the outside factor is on the left of the group or on the right. So we have 6 times 2 plus 6 times 3 plus 7 times 2 plus 7 times 3. We executed a distribution inside a distribution. Let's reorganize our result like this. 2 times 6 plus 2 times 7 plus 3 times 6 plus 3 times 7. In other words, each term of the first group multiplies every term of the second group. Again, the rule is each term inside the first group multiplies every term inside the second group. I guess I have to say something about FOIL. You probably learned to multiply two binomials like a plus b times c plus d using FOIL. Firsts, outsides, insides, lasts, giving ac plus ad plus bc plus bd. Now, this result is correct, but notice it is exactly what you would get with the rule we discovered in this video. So if the result is the same, why should you care? You should care for two important reasons. First, FOIL does not generalize. You cannot use FOIL to multiply even something as simple as A times the group B plus C. So FOIL is a dead end. Second, you cannot connect FOIL to the multiplication algorithm, a very important connect which we just made. Let's finish this video by multiplying 23 times 67, which we will do twice. Recall the rule is each term in the first group multiplies every term in the second group. So here is the multiplication showing the distributive property. Now the traditional way, which is the distributive property with shortcuts. And that is how multiplication distributes over addition.